Hi guys, as you already know, by applying the feedback to an op amp, we've seen that an op amp can do other things beside amplification. So in the last video, we saw the inverting amplifier. In this video, we are going to look at the non-inverting amplifier as well. So we will be solving for the gain of this circuit. As you know, the formula is the output voltage over the input voltage. Input voltage. By inspecting, we can see that the V plus is equals to the V in. And because of the negative feedback, by rule 4, we can write that V minus will be equals to the V plus, which is equals to the V in. So in order to solve for the gain, we need to come up with an expression relating the V in and V out. So if we use the voltage divider relation in this point, which is connected directly to the V minus terminal, we get the V minus to be equals to R1 over R1 plus R2 V out, which is equals to V in. So by rearranging this expression and calculating for the gain, let me write the gain here again, which is equal to V out V in. So we have V out. Now we know the V in is equal to this expression, so it's gonna be R1 plus R2 over V out R1. So V out cancels with V out, and we get the gain to be R1 plus R2 over R1. We can write it this form: 1 plus R2 over R1. So unlike the inverting amplifier, this circuit outputs a voltage which is in phase with its input voltage. So the output is non-inverted. So as the signal shows here, the graph, so if we apply this input signal, we're going to have the same signal in its output but amplified and in phase. we need to note that for a real op amp to minimize voltage offset errors due to input bias current, we need to set, or we would have to set the parallel of R1 and R2 to be equals to the R source. So for the next videos, we are going to see what else can the op amp use